Okay, so here's our first related rates example for Math 1560 Calculus 1 at U of L for fall 2017. We'll do a couple examples in the videos, and then we're going to do several more examples in class, as many examples as we have time for in class. And we generally work through these fairly slowly, so you don't have quite as much time as you might think to get through these examples. But we can probably get through maybe 4 or 5 of them in class. Okay. All right. So here's one. Well, actually, we kind of did this setup right in the previous video. I showed you how to set things up. So we're dealing with a sphere. So you might want to draw a picture of a sphere. It's not entirely necessary for you to draw the picture in this case. So we have 4/3 pi r cubed, gives me the volume. And now I'm thinking of, so v, right? V is a function of r here, right? But we're thinking of r as a function of t. So maybe r is, I don't know, like h of t, right? So then v looks like f of h of t. And so we know that when we want to take dv dt, the chain rule says you do f prime at h of t times h prime of t, right? That's the chain rule. So in other words, this is going to be dv dr times dr dt, right? So you can think of it as implicit differentiation if you want, but essentially we're just doing the chain rule. So what that gives us is dv dt. This is what we want. The rate at which the volume is changing in time is given by, so dv dr, so 3 comes down, 4 pi, we subtract 1 from the exponent, we get r squared, and then we multiply by dr dt. And now we simply plug in our values. So when r is equal to 5, we get 4 times 5 squared times our rate, okay, which is, so 5 squared is 25 times 4 is 100 pi, and it's probably a good idea to put in our units, cubic centimeters per minute. Okay, well, that was relatively straightforward. In the next video we'll look at something a little bit more complicated.